All right, you guys, for this, and I think probably for the rest of the year, I'm probably going to be doing notes again on video. So I just did them off video for a moment just because they were so new. I didn't feel comfortable unless I saw some kind of reaction from you or some kind of ability. Um, this is basically application, and I actually have taught this in class already, but I want you to remember it's just simply, sorry about my kitty. Okay, formula, substitution, and resolution. Okay, formula, substitution, and resolution. If my cat does, he's stepping on my board. Stay here. Okay. The main thing is understanding what kind of problem you have and what formula you're going to use. Okay, so what you don't want to look at is this, perhaps, is the title. What you want to do is look at the problem and realize what you're dealing with. And what you have is money invested at a certain percent interest. Okay, so if you're talking about money, you're going to be using the money formula. I mean, okay, the way Alex explains it is by using a simpler formula. But the reason why I want to use the money formula is because it works in every single case. And I think that's more important. Let me lock everything down real quick, by the way. Lock all. Okay, I think it's more important that you have a way to solve any and all problems. So you're going to be using this formula. So when you see money and you see that it's invested, you do A is equal to P times 1 plus R divided by N to the NT. Now, I've already given this formula to you. Okay, we've already talked about what every single one of these things means. Like I said, Alex will not give you this formula. It gives you the simplified formula because it says compounded annually. It becomes a much simpler formula, basically because the time is 1 year, the N is 1 year. So everything, when it's annually, if we substitute N is equal to 1 and T is equal to 1, it literally becomes this formula. Okay, but I'm just going to go ahead and do it this way because this way you have something to hang on to. Okay, it says a principle of, and I'm going to put A, okay, because it says how many years will it, oh wait, sorry, let me not do that. Let me not assume what we're doing here. Okay, let's read the problem first. That's probably the best thing. It says a principle of 4,200. So principle is P. So a lot of times it helps to do this on the side right here. Come on. What happened to my thing? Here it is. Okay, you go P equals 4,200. And then it says invested at 7% interest. So R is equal to 0.07 or 0.07, as you guys always say. Oop, I never put the 0 in front of the decimal. I wasn't brought up that way. Okay, N is equal to 1 because it says annually. So the number of times of year is 1. On the side here, I'm going to put this for you guys. If it says biannually, wait, how do I spell that? Annually? I don't think it's 2 N's. Yeah, it is. Biannually, okay, that means N is equal to 2. And if it says quarterly, that means N is equal to 4. Okay, if it says monthly, N is equal to 12. Okay, I just want to put this in parentheses for you. Okay, so N is equal to 1. And then it says how many years. So T is the thing we don't know. Okay, so we have everything else except for we need A. Okay, how many years will it take to accumulate 10,000 or more? So A is actually going to be equal to 10,000 or greater. So we want it greater than 10,000. So it's an inequality. But we remember when you solve inequalities, you just got to be careful about operating just, multiplying by positive or negative, but then just making sure you put it in the correct form. So we want the amount to be greater than 10,000, okay? So here we go. We're going to go 10,000, okay, is greater than or equal to 4,200, okay, times 1 plus R, which is 0.07 over 1, if you will, okay, to the 1 times 1. Okay, so you can see how it simplifies. All right, to the 1 to not 1, t, sorry, my bad. Okay, t. So, and I should have just put that there. If t was 1, but if n is 1, that's the formula. I gave that to you earlier. This is annual. This is the annual formula. Okay. Anyway, so here we are. Okay, so I'm going to erase that 1 just because it's distracting to me. Okay, so I'm going to just put t. There we go. All right. So now you're going to take 10,000 and divide by 4,200. Okay, and I'm not even going to actually calculate this yet, because as you get more advanced in math, you guys, you end up saving your calculations until the very end. It makes it a lot more accurate. Okay, so here we go. So you got 10,000 divided by 4,200. That's all we did, is equal to this. Now we need to get this little guy down. That's the problem. Remember, we have our exponent and it's in, we have the variable and it's in the exponent. So we need to bring it down. So the only way you know of bringing it down, and what you just learned, is to take the log. And I'm going to shrink it down to try to get more space here. Okay, so I'm going to take the log of both sides. So I'm going to write the word, taking the log means write the word log, okay? Log, here we go. I'm going to actually get back to blue. So I'm going to take the log of both sides. So 10,000 over 4,200, okay, greater than or equal to, okay, and then it's going to be log of 1 plus 0.07, and then we're going to bring down the t. I'm going to go ahead and put that in a different color because why not? So we brought down the t. Okay, so now all you have to do is to simplify. Okay, we got to solve for t, which means we have to get rid of this log. And why am I doing this? 1 plus 0.07 is 1.07. Okay, I don't know why I'm doing this whole time. Let's try doing a little math, Ms. Baca. Here we go. 1.07. I wasn't even thinking, I was just writing things down. Okay, so divide all sides by 1.07 log 1.07. This cancels. And now you have to plug that into the calculator. What does that actually mean? Just go ahead and, now we could do this as a subtraction, but I'm pretty sure you could just enter that in. As long as you just enter these into parentheses, you should be okay to enter all of this into the calculator. So let's go over here. Actually, you guys, while you're copying that down, I am going to write it down on a piece of paper so that I can enter it into the calculator for you. 10,000 divided by 4,200 divided by log 1.07. I'm sure I could use the division rule, but I don't see why I'd want to, Okay, so we're going to go to Desmos, which is right here. And you should be able to see my screen. Okay, yeah. Okay, so we're going to go LOG. And then we're going to go parentheses. And then we're going to do a fraction. And we are not going to put a 4. I don't know where that came from. I didn't do that. I didn't put the log 4 there. What the heck? Put a parentheses. Geez. Okay, log, and then we're going to hit the fraction. We're going to put 10,000. And on the bottom, we're going to put, what goes there? 4,200. Okay, close parentheses. Not there. Close parentheses here. I wonder how you do that. Is this how you do it? That's how you do it. And then we hit divided by. Oops, that didn't work. Let's try not doing that one. We should get rid of that here. Divided by, there we go, log 1.07. There you go. And there's your answer. 12.82. Okay, and what does it say? When you are reading this, be sure you're careful, wrong one. Be sure you're careful about what they're asking you for. It says, write the smallest possible whole number. Okay, answer. So How many years would it take? It doesn't say round up. So it looks to me like if it's 12.82, you can't say 13 years because 13 years is less. So it would say greater than 12 years. Greater than 13 years? Let's see. No, we need it to get to 13. It can't be 12. 12, you haven't reached the amount yet. So 13 is actually where you need to hit. So I guess it would have to be greater than 13. You can't put 12. It says put the smallest amount, but you can't put 12 because you haven't reached it until 12.8. So you're going to have to put 13 years instead. So the answer, okay, is T is going to be, has to be, wait, less than? Oh, ooh, that's interesting, you guys. How would you put that? It takes 12.82 years. And it says, be careful, let's see what it says. It says, how many years will it take to accumulate 10,000 or more? So it takes 12.82. Okay, it says write the smallest whole number possible. Okay, so the question is, why did I end up with T is less than, not T is greater than? Okay, I have a feeling it has to do when I divided by this, somehow it should have switched the inequality. T is going to have to be greater than or equal to 13 because it has to be more than 13 years. It can't be less than 13 years. So I guess check in Alex. I'm trying to think if I divided, when I divided by this, was I really dividing by a negative number and it ended up being, I need to switch my inequality. Let me check that really quick. Sorry guys, this is kind of interesting. Desmos, let's try Desmos. And let me just do log 107, just out of curiosity. Let's see, how do I clear? Everything clear all. There we go, log 1.04 or something, or 7 or whatever. It's less, it's small, but it's not negative. Okay, interesting. I've actually not really worked on inequalities before. So sometimes with these, I guess what I would do personally is just almost solve it like an equal sign and then logically figure out the answer. T is greater than, not less than. Why would I write less than? I literally said greater than, and then I wrote less than. T has to be greater than or equal to 13 years because you can't be 12. Oh, that makes sense. Okay, I wonder, did I just fill it out wrong? No, we want it to be greater. Oh, I filled it out initially wrong. Dum-dum. Look, you guys, we want the amount to be greater than 10,000. Duh. So right here is where I made my mistake. I hope you guys notice. Right here, I'm going to actually leave it written there so you can see my mistake and fix it on your own paper. Check it out. Right here is where I made my mistake. We don't want 10,000 to be the greatest amount. We want it to be at least 10,000. So the inequality should have been the other direction. Okay, that's why I ended up with the wrong answer at the end. Okay, so make sure you don't make that mistake. Okay, at least hopefully you'll learn from my mistakes or just logically think it through, honestly. Okay, let's go to the next one. All right, a laptop computer, let's read it and figure out what formula to use. Okay, it says a laptop computer is purchased for $3,900. Each year, its value is 80% of its value the year before. So in other words, it's depreciating, it's going down. Okay, after how many years will the laptop computer be worth 900 or less? Okay, here we go. So you basically have a problem of depreciation. This is the exponential growth or decay. The last one was too, but I prefer using the other formula with money just because it's just easier to always have that handy. Okay, so exponential decay. Y is equal to, it prints basically the first amount base to the x. And then the way it works typically is this is your initial amount, remember? Initial amount. Oh my God. Let's try writing, Ms. Baca. Initial. Okay, got it. B is going to be your rate, right? Okay, the rate. And if it's growth, I'm just reiterating this because we did it in class, but it's 1 plus R. And if it's depreciation, which is decay, it's 1 minus R, if you don't remember that. And X is usually time. Okay? And that is the final amount. This is a great reference to have. If you don't already have this down right now, you need to. Okay, get that down. I'm going to go ahead and shrink it down in a second. But this is the formula we're going to start with. Okay, so make sure you have this. So you have this at your handy. Let me see if I can. Oh, it's shrinking everything down, not just this little guy. Dang it. I wanted it to shrink down just my writing. That's interesting. Okay, whatever. I can work with this. We'll just work it up a little bit. Okay, here we go. Okay, it says, it says a laptop. Let's start writing down. This cord is, sorry guys. Okay, let's start writing down the actual, sorry, my cat is driving me crazy today. A is equal to P R to the T. Kind of, that's the way it looks. Okay. It's funny, that looks like the PERT formula. Almost is. All right, so we're going to go, and actually, I shouldn't, you know what, you guys, if you want to write it nicely, we can, instead of writing 1, it'd be 1 plus or minus R, just depending. For growth, that's growth. I'm just writing it with the right letters. This one is nice to go back to simply because it's the basic one, and it can always kind of guide you. It's always good. So anyway, there's growth, there's decay. Ow, ow. Okay, sorry. Okay, a laptop computer is purchased for $3,900. Okay, so that's the principal. That's the first thing, $3,900. Its value is 80% of the year before. So 1 minus, 80%. 80% is the value. It loses 20% of its value. So it would be 1 minus 20% or 1 minus 80%, 1 minus 20%, which is 80%. Hello. Okay, so we're going to go 1. If we wanted to, you can think about it either way, but the rate is 0.8. Okay, it's 80%. Okay, it would be 1 minus R. R is the rate of depreciation, which is 20%, right? Okay, after how many years will the laptop be worth 900 or less? Okay, so laptop is going to be worth 900 or less. So we're going to plug in A is equal to 900, and we'll figure out the inequality in a second, just so we know. Ow, God, my cat. I'm so sorry, you guys. Okay. All right. So let's go ahead and plug this in. Okay, so you write the formula first. Okay. And then we're going to go A is equal to P. Okay. Times, and then you know what? I don't want to put the 1 minus RT. I think we're just going to plug it in. We'll just use that one. Y is equal to A to the B, whatever. So we'll do A, which is 900, equals, okay, P, which is the principal beginning amount, 3,900, times 0.8 to the T. And the T is the question mark. Okay, and we want it to be less than 900. I hope I did that one right. That makes sense, right? Okay, the value is going to be less than 900. So you're going to divide by 3,900. Okay, same as we did before. Oh no. Oh shoot. Did I screw that up last time? I did indeed. Oh, I didn't. Okay. Just checking, making sure I didn't screw up last time. Okay. So you're left with this. Okay. Why are you being such a pain this morning? Oh my God. Okay, let me go ahead and move up here while you're copying that down, hopefully. All right, so here we go. So now you have this, and we're going to go ahead and cancel that out. Okay, so you get 900. I'm not going to calculate it again, just because it makes it better in the final amount, okay? You could easily change that to a decimal, you guys, and work with it from there. 0.8 to the t. Okay, now we need to bring this down, so we're going to take the log of both sides. So it's the same process. Log of 900 divided by 3900 greater than or equal to log of 0.8, okay, and we're going to bring down the t, okay? Then we're going to divide by log of 0.8 on both sides. Now it's basically just algebra, and you guys are not used to using whole words, but that's kind of what you just got to get used to with these logs. Okay, and now we just plug that into the calculator, okay? So again, I'm going to write this down. It's log 900 over 3900 over log of 0.8. So you come over here to Desmos. We're going to plug it in. Log of, and again, 3900, is it? No, it's 900 divided by 3900. Okay, here we go. And then we're going to move that over, close parentheses, divided by log. Oh, Kitty, why are you being such a pain today? Kitty is like the best kitty on planet Earth. And then I swear, the one time I try to record, he's all up in my business. Okay, and you don't need to put 0.8, but if that makes you feel better, do it. Okay, so 6.57. So that's the answer. 6.57. Let's come back. 6.57. Okay, so the question is, how do we understand that? T is less than or equal to 6.57. That's halfway through the year. So what does it say? It says, how many years will a laptop be worth 900 or less? Okay, so it's going to take it 6.5 years to get to 900. Oh. Okay, if it's 6.5 years to get to 900, okay, remember at 7 years, it's still worth more than 900. Okay, if at 7 years, it's worth more than 900, right? You can't put that. Okay, so you're going to have to put 6 years. Okay, the answer is 6 years. Okay. You guys, I hope you get that. In other words, like 7 years, at 7 years, it's 900, it's worth 900 and something. We don't know what. Okay, at 6 years, it's probably worth less, maybe 900, it's maybe less than 900, probably, obviously, because 6.5, it's 900. Okay, so less than, but we have to go with the smallest number. So 7 is the one that makes most sense to me anyway. Okay, all right, here we go. All right, right, did I accidentally copy the same problem? I did. Here we go. Let's try this one. Okay, it says finding the time given an exponential function with the base e. Okay, so now the only difference between this and the problem before is that now you're going to be using ln instead. So again, always go back to formula, substitution, resolution. So Hans places a bottle of water inside a cooler. As the water cools, its temperature, C of t, in Celsius, okay, is given by the following function, where T is the number of minutes since the bottle was placed in the cooler. Okay, so Celsius is given by time, okay? Your temperature is dependent on time. I love function notation. Hans wants to drink the water when it reaches a temperature of 16 degrees. How many minutes should he leave it in the cooler? This is again an inequality, okay, because we want it to be 16 degrees, basically. Actually, yeah, know what? We'll deal with it when we get the answer. Okay, we're going to put 16. So when we are looking at this, okay, we want to get it when C of t equals 16. Okay, the next thing, E is a number. You guys don't forget E is an actual number. Oh, so that's it. That's all we have to plug in because everything else is solved for. Like, look, E is a number, and then the only variable we have is t. So that works. So here we go. 16 is equal to 9 plus 11e to the negative 0.025t. Pigeons. Crazy little boy this morning, I swear. Okay, so again, here's our variable. Remember, in solving equations, all you have to do is, what do I want to get rid of? So the first thing we want to get rid of is this 9. So we're going to subtract 9 from both sides. I'm showing work just because of the first one. So we're going to subtract it, and you're going to get 11e to the negative 0.025t. Now, what do we want to get rid of? The 11. Divide by it. Okay, cancels. So now we've got 7 11s equals, and notice I'm not going to decimals yet. It just, you get a better accurate answer without calculating the intermediate. Actually, it says do not round any intermediate computations. Just don't do them. Just leave it like this. E to the negative 0, to train myself to write the 0. Okay, t. Now we have our variable in the exponent. So to get it down, we're going to need to take the log, but we're going to take the ln, okay, instead. So let me shrink this down a little. Okay, shrink it down. Come on, move it up a little. Okay. So what we're going to do is we're going to take the ln of both sides. Okay, ln of e, and then we're going to use the property that allows, that basically says these cancel each other out, and we're bringing this thing down. Okay, so we're going to get ln of 7 11ths is equal to negative 0.025t. And now all you have to do is divide both sides by this. Okay. Okay, and now we've solved for t. I highly recommend on the next problem, you guys try to do it ahead of me, okay? Or pause the video to try to see if you know how to do it so that you've got this, okay? All right. And don't forget that the reason why that ln went away, okay, is because this is actually equal to 1 and it goes away, okay? So, and we bring this one down. So you know why we did what we did. Okay, that was rule 3, and then ln e of e becomes 1. And if you need to write that down, I've written it so many times, but just in case. And that's because e to the 1 equals e, yeah? All right, cancels it out. It's nice because it basically cancels it out. All right, so we're going to plug that into our calculator now. Okay, here we go. So we get ln, let me clear all, ln of parentheses 7 divided by 11, close parentheses, bring it over, close parentheses, divided by negative 0.025. Yeah, and the answer is 18.079. Ooh, trick question. Okay, it's slightly over 18 minutes. Okay, because t was in minutes, correct? So it's 18.07. So if we had to answer, it's like t 18.07, and round it, but it's slightly over 18 minutes. So how many minutes should he leave it? It says round your answer to the nearest 10th. Oh, hey, here we don't have to. This is not an inequality. Okay, this is an equal sign. Okay, so it's 18 to the nearest 10th. So it's 18.1. I like when it's not inequalities, to be honest with you. Okay, and that's the answer. All right, for the next one, I recommend you try yourself to see if you could do this on your own. Okay, take a look at the equation. It's got e in it. Don't forget, e is not a variable. E is a number, 2.7 blah, blah, blah. Who cares? I don't know. It's a number. Okay, so there's only 2 variables here, this one and that one. And they're going to give you one of them, okay? And I can tell you that we're going to be solving for t because that's the new thing we're learning. All right, so it says the velocity in meters per second, that's important. Meters per second of a skydiver falling near the Earth's surface is given by the following exponential function, where t is the time after diving measured in seconds. So now time is in seconds, you guys. How many seconds after diving will the skydiver's velocity be? 43. Okay, that's all you have to do is plug in 43. V of t is equal to 43. That's what we're trying to find. So 43 is equal to 61 minus 61e to the negative 0.23t. I recommend you pause here and try to solve this, okay? Round your answer to the nearest tenth, okay? So we subtract 61, and you're going to get negative, I don't know why I can't do this one in my head, 18. All right, divide by negative 61. And then we get positive 18 over 61 is equal to this. And we're like, oh, we got to get rid of the e. We got to bring the t down. So we take the natural log of both sides. And I'm being a cheater. I'm just going to write the word ln right here. There. Now I don't have to write the whole thing all over again. Okay. And then we get ln of, oh, God, excuse me, I'm so sorry. 18 over 61, okay, is equal to, that's going to cancel out. This is going to come down. Me and my little circle thing, I always like to do that. Okay, and then divide both sides by negative 0.23. That's interesting. Okay, and let's see what we get. Okay, I'm going to write this down real quick. I have to write them down so that I can go to the next one. ln of 18, which is less than 1, by negative 0.23. I feel like this is going to be, no, wait, no, 43 meters per second. What's weird about this is that it starts at 61. Okay, I think, hang on a second, let's try this. So to get ln of 18 over 61, I might be crazy. I'm thinking of something. Let's see. 61 divided by, nope, okay, negative 0.23. Okay, we're good. Okay. Oh, okay, well, there you go. 18 over 61 divided by negative 0.23 is 5.3 seconds. Okay, it says to round to the nearest what? Round to the nearest tenth. So it was 5.30. So it's 5.3 seconds. Okay, and that's it. 5.3 seconds. Moving on. All right, here's another one. Okay, it's basically the exact same kind of problem. So if you're looking at it, again, all we're doing is plugging in things. Okay, here it says that we want it to be 47. So 53 minus 53e to the negative 0.26t. Okay, again, you're just going to subtract this. Okay, you're going to get negative 47 to 53 is 6. See if you guys can start to get the rhythm of this. Divide by negative 53, and then you'll get 6. Let's try that again. 6 over 53 is equal to e to the negative 0.26t. Then you take the ln of both sides. Okay. And then this will come down. And then you're going to divide this side by, well, it'll come down. Okay, divide by 0.26. And then you've got your answer. And I'm not even going to do it because it's not that hard. Okay, I think that might be it. Oh, no. Now we're going to the next kind of problem. Okay, these are continuous compound interest problems. When you see the word continuous means, okay, continuous is when continuous means use E, okay? So the idea is that you could compound interest once a year. You could compound it monthly at 12 times a year. You could compound it daily at 365. Or you could compound it hypothetically continuously, which means at any moment, okay? At any time of the day, all day, whatever, continuously, which is a crazy concept when you think about it. But this is how the banks calculate your interest and the money that you put in the bank. Okay, it's compounded with the basically using the function e, which is great. And so this is called the PERT formula, and this is what it is. It's P is equal to E times R to the T. Sorry. So you can see that it's basically similar to what we were doing before. Okay, so P is equal to, what am I doing? Oh my God, my brain, y'all, my brain. It's A is equal to, I was like, what? That doesn't make any sense. My brain, y'all, my brain. I know it. I don't know what's wrong with my brain. Okay, thank you. Thank you, brain. Thank you for coming back to me right now. That's it. That's the PERT formula. A is equal to PERT. Do you see how it spells the word PERT? A is equal to P times E to the RT. Basically, the exponential formula again, P is still the principal, A is still the amount, E is now your base, okay? Oh, shoot. Okay, here we go. Okay. So, sorry, my cat just, it's fun. Notes with the cat. Okay. Anyway, people refer to this often as the PERT formula. Okay, and it's nice because it's like, you can just always go back to it when you're compounding continuously. It's an easy one to remember. So, don't do that. Okay, go back up. So, says, let's start naming things, okay? Suppose 2,900 is borrowed, okay? So P is 2,900. For 7 years, T is equal to 7 at an interest rate of 0.09. R is, 9%, 0.09, okay? Compounded continuously, that means use the E. Find the amount owed, assuming no payments are made until the end, okay? So let's go ahead and start this, okay? So we're looking at, okay, how much is going to be owed if you borrow 2,900, right? Okay, times E to the 0.09 times 7, okay? And it's literally just plugging that in. So let's do that, okay? A is equal to 2,900 times E to the 0.09 times 7, which is like 0.63, but whatever. Okay, here we go. Let's go to Desmos. Okay, get rid of that. Okay, we're going to go 2,900 times E, where's E? E to the parentheses. Well, actually, I might not need that. I don't know. Maybe I didn't need to put a parentheses. 0.9 times 7, close parentheses. 5,445. Okay, that's your answer. 5,445.07. What does it want it? It wants it to the nearest cent, okay? So it's 5,445.07. And that's your answer. It's that simple. So look, you guys, look at this. In 7 years, you're almost doubling the amount. You wait, 29 is 58. Yeah, you're almost doubling the amount in 7 years. So you borrow 2,900. By the end of 7 years, you actually owe them almost twice as much. Isn't that crazy? That's why low interest rates are really important. All right, let's try again. Okay, your keyword here when you're reading is says initial amount of 1,300 is invested into an account at an interest rate of 4.5% compounded continuously. Once you read that, you know your formula, okay? Once you have your formula, all you need to do is start marking what things are, okay? Initial amount, remember that's your P, okay? So P is equal to 1,300. R is equal to 0.045. It's right here. Compounded continuously after 4 years. Okay, so t is equal to 4. So we plug it in. A is equal to 1300 times e to the 0.045 times 4. And you can do the calculation on that, because I don't think you need that help anymore. I don't think that's the hard part, okay? Last one, just in case, okay? Let's take a look. Oh, wait, this is the final amount. Okay, the last problems we're going to be doing finding the time. Okay, so again, this one, it says a bank offers 5.5% interest continuously, and he's going to deposit $1,600 after 5 years. Okay, so in case you need it, one more. Principal, 1,600 times E, which is a number, R is 0.055, okay, times 5. All right? All right. The next last bit we're going to be doing is going to be finding T. Okay, and to find T, we're going to be doing half time or doubling time. It's interesting, though. I don't have any. Nope, I don't. I don't have any where you're finding time with money, per se. Maybe they'll be in here. I can't remember if I put them in here. But this is basically finding half-lives or doubling time. So the idea is if you have double might be with a bunny. But if you have a half-life, if you have a radioactive substance, it has a certain number of molecules in the air. Let's say it has 1,000, okay, molecules. And let's say it takes 5 years to get to 500. Let's say it took 5 years to get there. That is called the half-life. The half-life is the time that it takes to get to half the amount. So in another 5 years, it'll be 250. And then in another 5 years, it'll be 125. And in another 5 years, it'll be half of that. You get the idea? It'll just keep going down. It'll never ever reach zero. It'll just keep going down. This is how they do carbon dating, you guys. They have a radioactive carbon molecule in the air that basically has a half-life of, I don't remember how many thousand years. So they measure the amount, and this is how they can do this. It's pretty cool, actually. This is hypothetical molecules. Some radioactive molecules have a half-life of split seconds. Like they literally exist for only a moment. A lot of these are used in the medical field. Maybe not a split moment, but for like minutes. Like if they want to take an X-ray of your gastro, like say maybe like your esophagus or your stomach or whatever, and they need to, or even your intestines, they might they might put barium in there, which has a much smaller half-life. I'm not sure if it's a day. That'd be interesting to find out. Ready? Real quick. Sorry. What is the half-life of barium? Because they put it in you, 153 seconds. So you can see that it's much less. So that basically gives them a couple minutes, I guess, to do that. That's really interesting. Okay. All right, here we go. Back to this one. Let's take a look at this. Okay, so we got, it says the number of bacteria in a certain sample increases. Okay, so let's talk about doubling the time. Okay, so this is having the time. You need to pay attention to which one you have. Okay, this is having the time. Okay, this is half-life. But when you're talking about growth, things like bacteria start with 1 cell and then it goes to 2. And then it has 2 cells and it goes to 4. And then it has 4 cells and it goes to 8, right? It keeps dividing and it keeps doubling each time. Okay, so this is doubling. And this gets exponential so quick. It starts slow and then, and you can see this kind of like with the virus as well. It's not quite, it never quite doubled, but it definitely increased. All right, here we go. It says the number, whatever, where Y0 is the initial a number. Not surprising, because here it is. They just named it a different letter. And Y is the present number. Okay, like this is now. This is now, And this is what they started with. This is always the starting. Remember, that's how it always works in these exponential equations, okay? How many hours does it take for the size of the sample to double? Okay, so interesting. We want y to be double. We'll come back to this. I just want you to pay attention to that for now. Do not round any intermediate computations and round your answer to the nearest tenth at the end, okay? So they didn't give you anything. What are you supposed to do? Okay, what you're going to do is you're going to actually put in y0 is going to be 1. Okay, we're going to start with 1. Let's pretend we just start with 1 because that's what we're going to win some, okay? And then we want the amount to double. So we're going to put y as 2, okay? And that's what we're going to do. So 2 equals y0 is 1, okay, times e to the 0.0264 t. Okay, now you take the natural log, because we're dealing with e, of both sides, and then you can bring this down, and the ln of e will go away, and you get ln of 2. And then you divide both sides by, here, all we're doing is division now, and now you have t. It's the log of 2 divided by 0.0264. The log of 2 divided by 0.0624. I hope I did that right. Let's see. It's about Desmos. It says I can fix it. Okay, here it is. 0.0264. 0.0264. 11.1. That's 11 point. It says round to the nearest tenth. So it's 11.1. Round to the nearest tenth. And time is in hours. Pay attention to the time. Okay, so it's going to take 11 hours at this rate. Okay? Oh, wait, it's 11.1 hours. It said round to the nearest tenth. Sorry, 11.1. My bad. 11.1 hours. Okay. I want to be asked, is there any questions? But I can't. Okay, let's try the next one. Okay, now we're talking about decay. It says, a radioactive substance decays according to the following function. Again, y0 is the initial amount, no surprise, and y is the present amount. Okay, y is the present amount, and time is in days. Okay, so whatever this decays, it decays in the time of days. By the way, and again, I've been kind of neglecting this formula, substitution, resolution. You know what's interesting, you guys, is that they actually date oldest rocks by a potassium radioactive molecule that's in the rocks. It's supposed to be Y0. That has a half-life of millions of years or something ridiculous like that. Okay, why is the amount present? Okay, so what we want to do in this case is we want to half the life, you guys. So we're going to assume Y0 is 1. Well, if we want to go half-life, that means y has to be 0.5. Get it? We're halving the life. Okay, so this is going to be 0.5 is equal to 1 times e to the negative 0.0645 t. Okay, to get rid of the e, ln of 0.5, ln e. Bring this down. Of 0.5, 0.5 for those of you that are so used to that. I'm sorry, I'm so bad about putting that initial 0. I guess because I just never had to do it in school. Okay, so t is equal to, all you have to do is plug that into the calculator. So let's check it out. Let's do it. ln of 0.5 divided by 0.0645. Okay, ln of 0.5 let me put 0 for y'all. Does that make it nice, more comfortable for you guys? I don't know. Backspace, negative 0.0625, what is that? No memory. I have no memory, 645, okay. Here we go, 645, boom, get back here, get down there, 645. All right, 10.7. And I'm rounding it to the nearest tenth, it's 10.7. So let's do this. Time is equal to 10.7, and in this case, we're talking about days, 10.7 days. Okay, so it takes almost 11 days for whatever this radioactive substance is to get half the amount. Okay. You know what does kind of work like this too, you guys, is medicine. When you take medicine like that they give you at, hello? Is there nothing else here? Hello? Yeah. That was weird. It's interesting. When you take medicine, it decays kind of at an exponential rate. So to try to keep medicine in your blood, that's why they tell you to take it every so often to try to keep that level up in your blood. Okay, the number of bacteria where Y0 is the initial, again, okay, and Y is the number present. Okay, how long does it take? How many hours? So we're looking for time. Okay, it's the same thing as you had before. So in this case, if we wanted to double, we put the amount on the left side as 2, Y0 is 1, e to the 0.046 t. And then you follow the same thing. I just wanted to set that up. It's really that simple. And if you're doing, I finally got a money one. Okay, here's the money one, finally. Okay, it's basically the money thing that we did before, except for this time, it says how many years. So we're going to be calculating time. Okay, so we're still going to write the same formula, right? A is equal to P, okay, times 1 minus R over N to the NT. Okay, I did this just because we can always come back to it. It's best to memorize the more complicated problem. If N is equal to, let's see what it is. We purchase it for 3,900, so P equals 3,900, okay? Each year its value is 80% of its value, okay? So that's what's going to go inside that parentheses, okay? Is going to be 80%. The rate is actually 20%, right? The rate down is 20% depreciation. So 1 minus 20% would be 80%. They're giving you the answer, whereas before they were giving you the depreciation. So I just want you to be prepared for both. After how many years will it be worth 900 or less? 900. Okay. So we want to go ahead and plug that. N is equal to 1. Okay. So we can get rid of the N because the N is just 1. If it's 1, it's 1. Okay. And 1 minus R is going to be 0.8. Okay. So we're going to plug things in here. Sorry, I'm going to erase this A because I don't need it. Okay, so A. A is 900. P is 3,900. And then we're going to go 0.8 to the T. See how I substituted in there? All we did was substitute in for this quantity is 0.8. Okay. All right. Divide by 3,900. Same thing as before, 0.8t. And now you can take the log of both sides. Now you can take the natural log here or you can take the log. It doesn't really matter. It depends on which one you feel like typing. I'm going to take the ln just because I feel like it. And then we can bring the t down, t. Divide both sides by ln of 0.8 and you're good. This is exactly like what we did before. Okay, the only difference is I chose to use ln. It doesn't matter if I use log or ln, the answer is going to be the same. Okay, and then you would plug that into your calculator and solve. I don't think I need to wait for you to do that. And I think that's it. All right,